Okay, so good afternoon, students, and let us start with the cantilever beams with uniformly distributed load. In our previous lectures, we have seen how to plot the shear force and bending moment diagram for point loads. So today, let us start with cantilever beam. Just take one example. This is beam. This is cantilever beam. So this cantilever beam, as you know, generally balconies, best example is balconies. You will get such cantilevers. So AB is your cantilever beam, and over it uniformly distributed load is acting. Just take intensity as 20 kilonewtons per meter. In engineering mechanics, you might have studied uniformly distributed load. Uniformly distributed loads are generally expressed in load per meter length. Let us assume that the span is 3 meters, suppose 3 meters. Our sign conventions to plot the shear force diagram, suppose this is your section and this is section left, this is section right. To the left of the section, we are considering upward force as positive and downward force as negative. To the right of the section, vice versa, upward force negative, downward force positive. Now if you wish to plot the shear force diagram for this cantilever beam, then first of all we have to see the reactive forces acting over this cantilever beam. This is AB. Reactive forces acting over this beam is fixed support at A and this is free end at B. So reactive force, fixed support will offer 3 reactions. One will be in vertical direction, one will be in horizontal direction, and one moment here like this is M. You can assume any direction, anti-clockwise, clockwise, whatever it is, you can assume any direction. Now let us start. Our basic aim is to plot the shear force diagram, a simple numerical shear force diagram for this cantilever beam. So force, so absolutely we need not, in case of moments we have to multiply force with distance or lever arm. But in shear force diagram is vertical unbalanced force. So we have to consider only the forces. Now if I consider this section XX and I decided to consider the left side of this section, it will be difficult for me because I will have to calculate all these reactive forces and then I will have to see and plot the shear force. But if I am considering the right side of the section at a distance x from free end B, then to the right side there are no reactive forces. So generally you consider the section in case of cantilever beams from the free end. Now let us start. First of all, try to develop the master equation Vxx. Vxx equal to right side, see the forces, only one uniformly distributed load is acting and that to 20 kilonewton per meter. So your intensity is 20 kilonewtons per meter multiplied by, because this is the master equation for shear force. So this uniformly distributed load, which is in terms of intensity, when you will multiply it by the length, intensity multiplied by the length or span, you will get the force. It is very simple. 20 kilonewtons per meter multiplied by x meters, which is the length to the right side of the section. So you will get 20 multiplied by x. So intensity multiplied by span or length of that UDL, you will get the force or load. Now you see here, this UDL is acting in downward direction, section right downward direction, it is positive. So it is positive. Now this section is valid. This section can move from B to A. So this section is valid from B to A. If section moves or slides towards B, this x value will decrease, and when this section will reach at B, this x value will be equal to 0. When this section will move and reach towards A, this x value will be 3 meters. So these are the two extremities or extreme boundary conditions for this section. Now try this shear force at A. If you wish to calculate the shear force at A, you have to substitute value 3 in place of x. So 20 into 3 is 60. And units will be, this is kilonewton per meter multiplied by meter. So units will be kilonewtons. As we are interested to plot only the shear force at A will be 60 kilonewtons. Now try to calculate the shear force at other extreme end, that is shear force at B. Now shear force at B will be equal to, when you will substitute the value 0, so you will get 0. Now start plotting it here. Our sign conventions to plot the shear force diagram is, we have to plot positive values above the horizontal axis and negative value below it. You can take vice versa also, it doesn't make any difference. So shear force at B is equal to 0. Shear force at A is positive 60. I am plotting above horizontal axis. So suppose this is your 60 value. This is 60. Now see the master equation. It is x means x to the power 1. So this equation is to the power 1, and when it is in the power to the power 1 means degree is 1, then you have to plot with straight line. No need to mention in case of straight line, but if you are plotting freehand sketch, mention here that the degree of the equation is 1, a value is positive. So in this way you can plot the shear force diagram for any cantilever beam. So I think students, it is clear to all of you how to plot the shear force diagram for cantilever beams. You can try few more examples for practice. This is the cantilever beam. You take this uniformly distributed load as say 25 kilonewtons per meter, and span of the cantilever you assume as 5 meters, and you can try this example and you can plot the shear force diagram. For this you can practice. So I hope you might have enjoyed this lecture. Thank you very much, students. Thank you.